Hi guys, this is the third video. This is note 7.8, polarity. I believe forces will be after this. So let's quickly go through this PowerPoint, which should be posted and it's not working. Okay, polar versus nonpolar. So first of all, these are all covalent, and covalent has shared electrons. If they're equally shared, it's nonpolar. If it's unequally shared, it's considered polar. And the way we tell the difference is using electronegativity. You can have polarity in a bond and overall in a molecule. And so in order to determine polarity, you're going to need that periodic table that I gave you that has the electronegativity numbers on it. So just a quick reminder, electronegativity is the ability to attract electrons to itself. So how much does something want to gain electrons? And generally the electronegativity increases up and to the right. Now the exception is these guys, the noble gases. They have zero electronegativity because they don't want any electrons. They're good. So everybody who has high electronegativity, I call them electron hogs or selfish. And again, it kind of increases this way. Fluorine is the highest electronegative element. So when we have equal sharing of electrons, we have some things that look like this, okay? And so generally, if they are symmetrical, they will have an equal sharing of electrons because they're kind of going to cancel each other out. If you are playing tug of rope with someone who is just as strong as you, probably no one will win because you have an equal balance between strengths. So here we have symmetrical molecules. And so even though in between each bond, so the bond between sulfur and carbon could be polar, overall this molecule is nonpolar because it's even, it's symmetrical, and they're going to cancel each other out. So here is just an illustration of what it looks like. So the red part here is where the electrons are spending most of their time because chlorine here is very electronegative and hydrogen is not very electronegative. And so we're going to have a partial negative charge, and that partial negative charge is where we get our polarity. Again, electron hog. All right, so polarity. First of all, we need to use the numbers on that chart, the electrons, electronegativity chart that you have on the periodic table that I gave you. If not, just look it up. And this is approximate, okay? There's no hard line for this. So we talked about 0.41 and less is nonpolar covalent bonds. So I'm going to make this at 0.4, it's considered nonpolar. Anything above 0.4 is going to then be considered polar, okay? So let's say 0.4 is nonpolar, and then anything greater than that is considered polar. Anything greater than 1, a difference of 1, so like if it was 2 minus 1, which gives you 1, that is considered very polar bond. And then anything 2 or greater, that's considered an ionic bond. Okay, there's no sharp dividing line for this. It's just an approximate guideline for this. So if we look at the bond between carbon and nitrogen here, the electronegativity difference, this is nitrogen's and this is carbon's electronegativity value off of the periodic table that I gave you. The difference is 0.5, so it is slightly polar. Now when we have carbon and oxygen, here's oxygen's 3.5 and here's carbon's, the difference is 1. This is a very polar bond. All right, so for this, to identify each one, again, you need that chart of the numbers. You'd subtract. Right away, I know that bromine bonded to bromine, that's going to be nonpolar because they're going to cancel each other out. It's going to be 0. Carbon to oxygen, we just solved that. That is going to be very polar. Chlorine and bromine, I can't tell you off the top of my head. You're going to have to look at those numbers and subtract. Now, I want to look at this one, carbon and hydrogen. The difference, once you subtract those two, is going to be 0.4. Again, I'm going to say that the 0.4 is going to be a nonpolar bond, okay? And anything above 0.4 will then be polar, okay? All right. So molecular polarity is determined by several things. So the structure or the shape, okay? The bond polarity, that's the difference in numbers, so like 3 minus 2 or whatever. And then are there lone pairs present on the central atom? And then polarity affects different physical properties, so things like melting points, boiling points, solubility, and we'll talk about that. Okay, so if you have a polar molecule, it's going to have something called a dipole, and it's represented by something like this. You have a plus end, which you point towards your positive end, and you have the arrow that's going to point towards where the negative area is going to be. We can also use things like partial positive and partial negative, but I mostly want you to focus on this. When I say show me the dipole, I mean this guy right here, the arrow with the plus, and where is it pointing? Okay, so for water, right, when you draw the Lewis dot structure, and you can see my other video for that if you still need help, we have our lone pairs that are going to be here up at the top, okay? If there are lone pairs on the central atom, that arrow always points towards wherever the lone pairs are. Always the end, it doesn't matter, whatever else is there, okay? Now, for this, there are no lone pairs on the central atom, okay? Yes, chlorine has lone pairs, but that doesn't matter. We don't care about that. We only care about, does the central atom have lone pairs? If it doesn't, then we're going to look at whatever else it's connected to. So hydrogen, 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 and oh, we have a chlorine. So we're going to point our arrow towards whichever is the most electronegative of something like this. Well, chlorine is definitely the most electronegative out of the rest of these. So hydrogens are going to have that partial positive, which you don't have to worry about. I only care about this dipole arrow. Okay, nonpolar molecules can contain polar bonds. However, their symmetry will cancel it out. Okay, so in carbon dioxide, this bond between carbon and oxygen is very polar. Same here. But because you have the same thing on either side, the symmetry cancels it out. Same thing with here. Everything is the same on the outside, unlike in previously where there was hydrogen, 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 and a chlorine. Now everything is going to cancel each other out. You have zero dipoles. So do not draw dipoles for either of those things. Okay, so in order to figure this out, you first need to draw a proper Lewis structure. Again, see my other video for that. You have to determine the electronegativity of the atoms, which is the subtraction of the values using the periodic table I gave you, and then ask, is it symmetrical? Now take a look at this diagram. Yes, I know it can be overwhelming, but for your question is it symmetrical? If the answer is yes, then you ask yourself, are they the same all on the outer atom? So are they all carbons? Are they all hydrogens? Are they all chlorines? If the answer is yes, it's nonpolar. If the answer is no, you want to check all of the electronegativities. Okay, so what are the electronegativity numbers? Are they different? If they're all the same, nonpolar. If they are not all the same, then it is polar. Okay, so like if I have 3 hydrogens and 1 chlorine, they are not all the same, and so they're going to be polar. If the answer is no, it is not symmetrical, the next question is, are there lone pairs on the central atom? If the answer is no, again, check all the electronegativities. If they're all the same, nonpolar. If they are not all the same, it is polar. If it has lone pairs on the central atom, it automatically is polar. Okay, so here we're going to determine the polarity and the dipoles. So we have HCl, and I can't really draw on here, I don't think. Let me see. Pen. Okay, we have H. Oh, this is going to take forever. This is ridiculous. Okay, H and Cl. Okay, first is it symmetrical? Well, no, because we don't have the same thing on either side. If we had the same thing on either side, then yeah, it'd be symmetrical. The second question is, well, let's check the the polarity difference. Well, hydrogen has a very low electronegativity and chlorine has a very high electronegativity. So you are going to point your dipole towards, oh, that's terrible, towards the most electronegative element. Okay. For NH3, when you draw this out, oh, it takes forever. Okay, we have H here. That's just an H. Okay, guys, this is also an H and an H because it's going to take too long. You'll see, though, that it has lone pairs on the central atom. Automatically, it's polar, and you point that dipole towards wherever you have drawn your lone pairs on the central atom only. It doesn't matter if any of the outer things have lone pairs. does not matter. Here we have carbon, and it's going to be surrounded by 4 chlorines. That's going to be symmetrical, so it will have no dipole. So you do not draw a dipole arrow there. BF3, now be careful because B is one of those odd ones that can do some weird things, and that is it only forms 3 bonds. This is going to be a trigonal planar. Okay, so there is no lone pairs. Oh, that was weird. Okay, so this is going to be symmetrical, so this has no dipole. And then CH3Cl, you're going to have H, 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 and then you're going to have a Cl, and here's my Cl. Sorry, guys, this is terrible. And Cl is the most electronegative. Okay, so it's going to point up towards that Cl. Sorry, guys, for the animation. That was terrible. But anyway, please let me know if you guys have any more questions. This corresponds to the 7.8 classwork. I'm pretty sure that key is up there. If it's not and you want to take a look at it, please send me an email. Let me know if there's any others that you guys want me to go through.